Assalamualaikum and hi everyone. So welcome back to my channel. So as you can see for the previous video we talked about potassium, but today we are not going to talk about potassium anymore, but what are we going to talk? As you can see here in front of us, there is a model here, so we are going to talk about this today. So before I forget, as you can see here we have the same guest as before. Okay, my name is Siti Nuratika binti Yusuf.
And my name is Maizatul Zaifatin Muzaffar.
And my name is Ilingo. My name is Jacqueline Liu Peizu.
Okay, so of course you all have already known our guest right from the previous video. So today we are going to talk about this model. We have given a special task to make a model. So as you can see here, there is a model of element we choose element SF6. And this model, what is it? We call it octahedral. And it is this we make it ourselves. Okay. By using. Okay, as you can see here, we use straw to make the model and ribbon and plasticine and a cardboard to make its atom over here. So this is what we made. As you can see here. So today we're just not going to talk about how we make the model, but we are going to talk about how to determine its point group for this model for SF6. So to determine a point group, first we need to know the symmetry elements and its operation. So what is symmetry element and what is operation? Symmetry operation. So symmetry elements is symmetry operations carried out with respect to lines, points or planes, and for the symmetry operation, an operation performed on object which leaves it indistinguishable from a superimposable on the original configuration. So as you know, there are 5 operations that include in this, which is rotation, reflection, identity, inversion, and rotation reflection. So without wasting any time, I'm not going to talk much about this because our guest here going to talk about this. So let's ask our guest to let me ask you how to determine a point group. First, what we need to do.
Determine the rotation.
Rotation. Okay. So how should we determine the rotation?
That's my part now.
Okay.
Yes, as my friend say, we have to find out the point group of this octahedral. So first we have to find out the rotation. Okay. As you can see here inside is a square, right? Here, a square. This plane is a square. So from here you have a C4. How to identify this is C4? First, we can turn it. Okay, from here C4. Turn the 90 degrees, which is have the same size, which is the model does not change the size, and then we turn another 90 degree, have the same thing. So means that this model have the C4 rotation. Next, from here also we have C2. Oh, before I forgot that we have 3 C4. How can I determine? From here is the x-axis, y-axis, and here is a z-axis. So to remember that octahedral have 3 regarding to the axis, which is C4. C4. Yeah. Then after that, we have C2 also. C2, same thing from here. C2. Then we rotate. C2 have the option of 180 degrees of rotation. So we rotate from here, rotate 180 degrees from top to the bottom. Then we can see that, we can know that this model does not change its shape. So we can determine it have a C2. And in this model, we have 9 C2. From here, you can saw it how the C2 in the model. Next, we have C3 also. From C3 is from here, this side. So have to look at the model like this, then we turn it like this. From here, have a, like for example, here is the C3 from here, so we can rotate from here. So we rotate in 120 degrees. The shapes does not change like this. 1, 2, and 3. So we can know that the model have C3, and this model have full C3, which is here and here and here and here also, which is from here, 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 and here. I think that's all from me. I think that's the next step to find out the point group.
So we have seen the step of rotation, right? Rotation. So next we are going to see for reflection, right? Okay.
Okay, now is my part. I'm talking about the refraction of this model. We got two types of refraction in this model, which is horizontal refraction and diagonal refraction. For horizontal refraction, as we know, horizontal is like this. So the refraction must occur in a horizontal plane in this model. So the horizontal refraction must cut over here. So then the fluorine atom above and the below will occur refraction, which this atom will change to here and this atom will change to above. This is horizontal refraction. And we got three horizontal refraction in this model, which is here, here, and here. Okay, now I'm talking about the diagonal refraction. What is diagonal? Diagonal is passing through the origin with highest axis of symmetry by setting the angle between two folded axes perpendicular to the symmetry axis. So in this model, as we know that C2 is over here, so the sigma d is over here. This is diagonal refraction. So diagonal refraction, we should pass through the highest axis of symmetry C4 here and pass through the origin. Then here it will form a perpendicular with the C2 axis. So there is a 90 degrees Celsius over here. This is sigma d. In this model, we got 9 sigma d as we can look in this model. Okay, I think that's all for me.
So we have learned for the reflection. So next let's move the rest to how to determine the point group.
Next, I will talk about the center of symmetry, which is inversion. So, the center of symmetry is located at this S atom, at the center S atom. So, why we call it center of symmetry? Because as we see, for example, if the distance from S to this F is from the coordinate is 3.
For
Okay.
example,
For example, if the distance from S to this right F is positive 3, then the distance from S here to this left S is negative 3, then we can call it inversion, which is its center of symmetry. So next is rotation reflection. Okay, so in this octahedral, we have S4 and S6 rotation reflection. We have 3 S4, which is here, 1, 2, 2, and 3. We have 3 as 4. Then we have 4 as 6. Here, 1 and 2, 3, here, and 4. Like this. Okay. As you can see here. So, to determine the point group of octahedral, we need to follow the flow chart as shown. Okay, so first, um, so so we have to look for the group of low symmetry. We need to choose whether it yes or no. If yes, we need to identify whether it has C1, CS, or CI. Then, if the answer is no, we proceed to the next step, which is we identify whether it has group of high symmetry. Okay, the group of high symmetry is special, which is if it is octahedral, tetrahedral, and icosahedral, then the point group of the symmetry is OH. So the point group of the octahedral is OH. Okay, so that's all. As you know, the 5 operation to determine the point group. So we have know the point group for octahedral is OH. Okay, so that's all from us. Thank you. Bye bye.